What should we do for our project?
I don't know. Let's look at examples in the book.
Okay.
Well, we could do population increase, spread of a rumor, or spread of a virus.
We could, but I feel like those are kind of boring. I want to get the best grade we can. We should try to do a logarithmic equation.
What type of topic, though?
I don't know. Hey, Nan, did you feel that shaking? What was it? An earthquake? I thought we didn't have those in Maine. Really? That was scary. I didn't know what it was, so I called you. No way. I'll have to tell Kayla. Okay, see you later. Bye.
So what'd your grandmother say?
She said it was an earthquake, and I guess the news said it was a 5.5 on the Richter scale.
No way. That's pretty bad, especially for Maine.
I know, but I guess when she was 10, there was an earthquake, and it was an 8.5 on the Richter scale.
That's crazy, but I have the best idea ever. Why don't we just do our math project on earthquakes? That way we can use a logarithmic equation and hopefully get a really good grade.
Yeah, that sounds awesome. So we know that the earthquake number 1, which was in 1964, was an 8.5 on the Richter scale. We also know that earthquake number 2, which was in 2014, was a 5.5 on the Richter scale. So we're going to use this equation, log A1 over T plus B minus log A2 over T plus B equals R1 minus R2 to find out the worstness of earthquake number 1 compared to earthquake number 2. So we're going to take log A1 over T minus log A2 over T, and our B's cancel out so we don't need to write them, equals our first Richter scale, which was 8.5, minus our second Richter scale, which was 5.5. We're then going to cancel out the T's, and we're going to be left with log A1 over A2, which would equal 3. We then take A1 over A2 equals 3, and we know that this is 10 to the third, which is also 1,000. So we now know earthquake number 1 was 1,000 times worse than earthquake number 2. Instead of going through all the steps we did before, we can do a shortcut. And that equation is A1 over A2 equals 10 to the first Richter scale, which was 8.5, minus our second Richter scale, which was 5.5. We then get A1 over A2 equals 10 to the third, which is also equal to 1,000, like we said before, times worse. So this is also the way to find out how much worse earthquake number 1 is compared to earthquake number 2. So what we're trying to figure out right now is if we had a future earthquake, which was 4 times worse, what would it be on the Richter scale? So we're going to use this to kind of help us out, and we're going to do x minus 5.5 log 10 equals log 4. So we know that log 10 is also equal to 1, so we're going to do x minus 5.5, 1 equals, and we're going to insert that into the calculator, and you get 0.602. We're then going to divide each side by 1, and you're going to get x minus 5.5 is equal to 0.602. We're going to add 5.5 to each side, and x is equal to 6.1. So then we know that if an earthquake was 4 times worse than the one that we had, then it would be a 6.1 on the Richter scale. What we're going to do is we're going to solve by graphing. So we're going to use the same equation we did earlier and almost the same problem, but we're going to do 15 instead of 4. So if an earthquake was 15 times worse than the one that we had, what would it be on the Richter scale? So first we have y1, which is equal to 10 to the x minus 5.5. We're also going to put y2 is equal to 15 because 15 is how many times worse. We're then going to press save, and we have our equation. So wherever it meets the intersection is what it's going to be on the Richter scale. So we're going to press trace, and we're going to snap to intersection /roots, and we're going to drag our little dot into the middle where they intersect, and up at the top it's going to say x equals 6.676, and that's roughly x equals 6.68. So therefore, if an earthquake was 15 times worse, then it's going to be x equals 6.68 on the Richter scale.
We know the numbers in our equations are correct because A equals amplitude in micrometers, T equals period of the associated seismic wave in seconds, and B equals weakening of the seismic wave with increasing distance from the epicenter of the earthquake. We used a logarithmic equation because the equation was already set up and given to us. Also, a linear equation goes up by 1 as a logarithmic equation goes up by multiplying 10. This allows you to have a wide variety of numbers on the same page that is easier and more simple to follow.